This video, here we will be learning about quadratic inequalities. So that's basically a quadratic equation where instead of equal sign you have either bigger than, smaller than. So let's look at an example here. First of all, if we look at this graph, if you had to picture it, you factorize the quadratic if you can, and you find the solution to it as if it was equal to zero. Notice my words, I'm not saying set it equal to zero, but you would vectorize it and you find the solutions if it was equal to zero. So the factors would be minus 5 plus 1 inside the bracket. So when you take them out of the bracket, the solutions will be x equal to 1 and x equals to 5. Now, this is if it was equal to 0. So we found where it cuts the x-axis here. What we did is, yes, I know we changed the problem, but this is how we need to solve it. So once you plot the graph, why is it this smiley face? Because there is a plus sign, this number in front, the a coefficient of x squared is positive. So it looks like a smiley face, doesn't it? All right, happy. Now, then you say for what values this this represents y, okay? All right, doesn't it? This function of x is y value, isn't it? So really, we're looking for y values that are less than 0. All right. So that's why this blue line is going under the x-axis. All right, means under the x-axis for less than 0. So that's why you're going to say what x values will take me down here. These x values have to be strictly less than 5 and strictly bigger than 1. What I mean strictly is don't put equality sign between here. Don't draw another line under it. You could have, but because there is no underlining here under the inequality, it cannot be equal to. So here the answer cannot be equal to either. So that's how you write your answer, or you use set notation like we learned previously. All right. So now the next question, if you set this quadratic to equal to 0 and solve for the answers, you find the roots of the inequalities. Because of the minus 2 in front of x squared, you draw a sad looking graph for yourself and you say this uh, definition is y for y value. Y is less than 0. So in this case, this means y is less than 0 means go under the x-axis one more time, here and here. Now, if I'm exaggerating the shape of the graph because it would be something like so, wouldn't it? If you're going under the graph, under the x-axis, x values have to be less than minus 3 and x values have to be bigger than a half. So to the right of this value goes under, and to the left of this x coordinate it goes under. So that's why you're gonna write the disjoint set, means that you're gonna use or, yeah, or x has to be less than minus 3 or x has to be bigger than half. So when you have or sign, or means use the union sign. All right, you're going to use the U shape here and put that between the two sets here. Okay, disjoint. These 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 two sets are not connected. So this word disjoint means between them. So next question is saying find the values of k for which this equation has two real roots. All right. The word real means that it is two distinct values. If you study further maths, you know actually this equation could have a complex root, but we know talking about that in pure maths here. Alright, so we have two real roots. What does that imply? It implies that b squared minus 4ac must be positive. Yes, okay. So we're gonna take the a value here. This is our a. A is k plus 3. B is only 6. And c is k minus 5. So we're gonna take those values, substitute them into the inequality, and once you multiply this bracket here, you have 36 minus 4 k squared minus 5 plus 3 makes minus 2k, and minus 15 here. Now multiply that by negative 4, you end up with negative 4k squared plus 8k, 60, that's a plus 60, and my plus 6 has to be bigger than 0. Now you remember dividing, if I just simplify this number is 96. All of them divide by 4 anyway, so they have a common factor of 4. So we can factorize negative 4 out of them and divide this inequality by minus 4. So we end up with, let's just factorize this carefully. Because I'm dividing by minus 4, this 8 becomes minus, and 96 divided by 4 is 24 here. So that's a minus 24 because I'm dividing by negative 4. Now, now I'm going to divide by negative 4. So this inequality will flip. Uh, sorry, the signs here remain as they are. The inequality sign will flip. Alright, so now trying to solve this inequality. Now, part A of this question is just saying show that. Uh, so find the value. Actually, yes, we are looking for value of k. So yeah, the question is saying find value, the possible values of k. So now we're gonna trying to factorize this, setting it equal to 0 means looking for the factors of negative 24 that add up to minus 2. So that's 6 and 4, isn't it? So I'm going to write minus 6 plus 4 inside the bracket. So I always write them out, and then that gives us a positive 6, and it was a plus 4 inside the bracket. So it's a minus 4 here. So when I'm looking at this, this I've turned it into positive. It did have a negative sign here, but I turned it into a positive quadratic. Dividing by a factor minus 4 leaves the roots as they would have anyway. So it's a positive quadratic, so it will have this kind of a shape. Then it will be symmetric as well. So you say the minus 4 goes on the left and 6 goes on the right. So it's important to get them in the right place, and then you say I want this y, this represents y, okay, this definition of k squared blah blah blah. I'm plotting it on the y-axis. Let's say it's not x anymore, it's k against y. So y is under the, y is below 0, so that means go under the k-axis here, and what values of k will take me down there. Let me just make the graph a bit neater. Right, remove that line there. So what values of k will take me down there? K has to be strictly less than, because here we have a strict inequality. So k is less than 6 and k is bigger than minus 4. So k dot dot, this is writing in set notation. So k is such that k is between minus 4 and positive 6. Alright, so let's see if there is another question to look at. So in this next example, we're considering to solve this equation where x is in the denominator. Now, most students make this common error. Let's just, this is a valid error, it's fine. They multiply both sides of this inequality by x. So here they write 2x is less than 6 and x is less than, then they divide by 2. So here they multiply by x and they divide by 2 and they get x is less than 3. Now, is that a valid answer? They're saying x is not 0. Alright, yeah, okay, it's not 0, we're not dividing by 0, right? But this is not a valid answer. Alright, why? Why is it not valid? Because you don't know, x could be a negative value. X is not 0, but it could be less than 0, and you would actually need to have flip this inequality. But you know to flip it or not? No, you don't know. We don't know when x is in the denominator here if x is positive or not, or positive or negative. So we don't know whether we need to flip the inequality sign or not. Remember, we went through all that business of showing you we need to flip inequality if it's a negative value. So if you didn't watch those videos, go back a couple of videos back. I showed you why you need to flip inequality. So how do we deal with this problem then? We need to solve it. To make sure that we divide, to make sure we divide by a positive value, or actually we multiply. We multiplied by x, didn't we? We multiply by positive value, positive x. We square x, alright. It's fine. We can multiply both sides by x squared. So instead we write 6 over x. If I rewrite the equation again, we multiply by x squared. That's allowed. What you do to the left, as long as you do to the right, that's allowed. Okay. So this time, because why do we do that? Because x squared is always positive. Alright. X squared is always bigger than 0. Alright. So if we do that, what we get is 6x actually is bigger than 2x squared. Now you can subtract both 6x from both sides with 2x squared minus 6x is less than 0, and you solve this inequality to get your answers. I can factor a 2x out of this equation here. Well, it's not an equation, I should say inequality. So I get x minus 3. So that's telling me either x is 0 or x is 3, x positive 3. So when I plot this, the sign in front of x squared is positive 2. So I draw sketch a smiley face. 0 is here and 3 is here, and I'm looking for y value to be less than 0 because this is the definition for y. So which values take me under the x-axis? Y is less than 0 for any value, x value that is between 0 and 3. So x is dot dot such that this is the correct answer. Now, what's this? Yes, you would have not known where you need to bound the x values here. This would have been still wrong. Yes, it looks like you got some part of the answer, but any value below, if you go x below 0, these wouldn't, negative values wouldn't help, okay? So this is the correct way to do it. Now, this is a simple example actually, because you just got x. You can guess. Maybe you say, "Oh, I could have guessed to found. I could have," but there are more complicated example. For example, you might have had, I don't know, 6 over x minus 5 is bigger than 2. So then you will, in that case, what you do is multiply both sides by the square of this whole term here. So you would actually multiply by x minus 5 squared both sides of the inequality. So you get 6 times x minus 5, you get an extra factor on top of the numerator, and it's bigger than 2 lots of x minus 5 squared. You can continue solving that. I'm not doing that in this video, but you just have to do that. Let's see if there's another question. Let's see. Here's the same question still, but you, after multiplying by x squared, you might have decided to subtract 2x squared from both sides. There's nothing wrong with doing that, as long as you draw your graph correctly. In this case, you would, rather than a smiley face, you need to draw a sad face graph. When you draw that and you put these roots on the graph, 0 and 3, still when you solve this equation, inequality, you say y is bigger than y, this is definition of y, so y needs to be above 0. You looking for this section of the graph, it will give you the same answer. You say x has to be between 0 and 3. Alright, so good luck practicing this equation inequality, part A, B, and part uh, 1I of B. If you remember, I'm going to show you the answer. The question says find the range of possible values for k. So once you got to this stage here, you would have to solve this inequality here. So I can do that here by first of all solving this equation as if it was equal to 0. So I write 3k squared. Actually, I'm going to remove the 3. Right, k squared plus 2k, and then write minus 3 here because I'm multiplying that minus 1 by this 3. I removed it. So now I'm looking to factorize this. What are the factors? It would have to be plus 3 minus 1 inside the bracket. So k minus 3 and k is equal to plus 1. So when I plot it, this inequality, this equation here has a plus sign in front of it. It did have a minus sign, we removed it. So the negative 3 is on the left, 1 is on the right, and we're looking for y values. This is definition for y below 0. So we're looking for this section, so x, or rather k, has to be less than 1 and bigger than minus 3. There is not an equality sign here, so I'm not going to put equality sign in my answer. If there was, you could have put equality sign here and here. Alright, so there you go. You could write it neatly like so. Curly bracket to indicate set notation. Alright, so that answers that part of the problem, and we already solved this. Next question says find two possible values for k in last part of the problem. And once, if you remember, I solved this in the last video, there was two possible answers for k, and that's fine.